Good afternoon, everybody. Today we are diving into the fascinating world of analyzing massive databases generated by social networks. Think Facebook, Twitter, LinkedIn. These platforms aren't just for connecting. They are unprecedented data sources for understanding human behavior, influence, and information flow. Our goal is to see how we can handle this scale and what valuable insight we can extract. Exploring the cutting edge techniques and technologies that enable us to understand and process massive social graphs containing billions of collections in today's intellectual digital landscape. The scale of social media networks today. Maximum ages, large dataset nodes, Facebook Snap datasets. Facebook scale graph can reach up to 1 trillion edges, fundamentally transforming how we approach data analysis at unprecedented scale. Live Journal's network contained 4.8 million nodes with 69 million edges, representing one of the largest publicly available social graphs. Facebook Snap dataset. Stanford's connections collection includes a Facebook dataset with 4,000 nodes and 88,000 edges, perfect for research and benchmarking. Uh, Real-world social networks encompasses remarkable complexity signed edges that capture trust and distrust relationship. Temporal dynamics showing how connections evolve over time, and multi-layer interactions representing different types of datasets simultaneously. Mapping billions of connections, this visualization captures the breathtaking complexity of modern social graphs where billions of individual connections from form integrate patterns that reveal the hidden structure of human interactions at a global scale. Core concept in social network analysis. Fundamental building blocks. Nodes represents individuals or entities within the network, while edges captures the relationships or interactions connecting them. Network types can vary significantly. EO networks focus on a single node's immediate connections, providing intimate views of individual influence, whereas whole networks examine entire system to reveal macro level patterns. Essential metrics. Centrality measures betweenness and page rank identify influential nodes. Density quantifies how interconnected the network is. Shortest path reveals efficient communication routes. Community detection uncovers natural grouping. Through these analytical tools, SNA reveals hidden influence who shape opinions, identifies communication uh, between the impaired information flow, and exposes the structure pattern that define the network behavior. The challenge scaling analysis to massive graphs. Traditional tool limitations. Conventional SNA tools reach breaking points beyond millions of nodes and edges, constrained by availability of a memory and computational capacity that simply cannot handle modern social network scales. Distributed processing required. Complex analytical workflows demand distributed processing frameworks such as MapReduce and Apache Graph, which pa- which which partition massive graphs across multiple machines for parallel computation. Facebook innovation. Facebook's pioneering enhancement to ggraph enable processing of graphs containing one up to 1 trillion edges, powering critical applications including content ranking algorithms and friend recommendation system. Breakthrough graph neural network at scale. Learning from structures. GNNs revolutionized graph analysis by learning directly from network structure to predict node properties, anticipate link formation, and identify communication membership pattern with remarkable accuracy. Industrial scale platform. Snapchat's GIGL platform represents a quantum leap enabling disturbed training and interference on industrial scale. Social graph that provide real-time recommendation for millions of users. Production impact. GIGL has powered over 35 production launches in front and content recommendation system, tangible real-world implementation across the approach of enterprise. Case study: topic level social influence modeling, topical affinity propagation or TAF. TAF model influences influenced by specific topic, recognizing that individuals may be influenced in technology discussions but not in fashion, differentiating social influence sources with unprecedented guarantee. Distributed learning. TAP leverages distributed learning frameworks under MapReduce architecture, enabling it enabling it to scale efficiently to networks containing millions of nodes while maintaining analytic precision. Practical applications. Applications include identifying key influencers within specific topic domains and quantifying the precise strength of neighbor influencer, enabling targeting intervention and content strategies. Insight from large scale social data sets. Sorry, insights from large scale social data analysis. Misinformation dynamics. Analysis of millions of tweets revealed that misinformation spreads with significantly stronger negative emotions content compared to truthful information, exploiting psychological vulnerabilities. Con- Contagion models, emotional contagion, and rumor evaluations model. Emotional contagion and rumor evaluation models explain how misinformation intensifies as it propagates through networks, gaining emotional charge with each reshare. Platform intervention. Understanding this dynamic enables the design intervention curb misinformation spread on the platform like Facebook, Reddit, or YouTube, and protecting information ecosystem. Tools and techniques for practitioners. Essential tools feature scalable visualization, handle handle large network with responsive interactive displays, centrally metrics, calculate information influence and importance, measures efficiently, data integration, seamless import and export across multiple formats, security features, protect sensitive social network data, distributive storage SDFC storing massive files across commodity hardware, distributed processing, Apache Spark, in-memory processing engine, fast parallel analysis and iterative graph algorithms, streaming architecture, Kafka, ingesting and processing real-time data feeds for instant insight. Example, detecting viral content immediately. Cloud computing scale utilizes scale on demand resources AWS Azure to manage fluctuating workload. None of this analysis is possible without a robust big data infrastructure. We rely on system designs and for parallel processing. Apache Spark is a workhorse. Here, his ability to perform fast iterative calculations in is critical for complex graph algorithm like PageRank. Furthermore, to handle the live stream of posts and interaction, we use technologies like Kafka to build real-time monitoring dashboards. Future of large scale social networks analysis, real time insights. Continued advances in distributed graph machines learning will enable real time personalized social insights that adapt to individual behavior patterns instantaneously. Multimodal integration. Integration of temporal signed and multimodal data streams will deepen our understanding of social dynamics, capturing the full richness of human interactions. Ethical framework. Privacy and ethical consideration will fundamentally shape responsible analysis and development and deployment, ensuring technology services society best interest. And in the end, in the conclusion, analyzing massive social data is a complex endeavor that sits at the intersection of computer science and sociology. While the technical capabilities are rapidly evolving, we must always address the ethical implications. Data privacy is paramount, and we must be vigilant about the inherent biases present in both social network data and algorithms we use to analyze it. It's about harnessing power responsibility. Thank you.